Hi guys. Now, following our last tutorial, somebody made a comment, and just so you know, your comment is appreciated and it is noted. So I've come up with this illustration. Now, some of the points that we highlighted, why we have to make our application a microservice, were fault, isolation, maintainability, and scalability. Of course, there is more, but focusing on this three, look at this is what we had in our first series. This is what we came up with. Our application is all in one stack. Our code is all resided here, and all other parts of the application, as you can see, the account service, the payment service, all going down to one database. So if there is a fault in the account service, all of the services are going to be down. The payment service will be down, and this is going to be down. Or if there is a bug or something that is preventing this application from starting up, it's going to affect every other part of the service. Now, it's not easy to maintain because there's so many parts of the application. It's robust. Imagine that you have, say, 10 other services, 20 or even more. It's going to be very difficult to, maintain this application, as it were. So what we are trying to achieve is microservice. And you can see this diagram. There are a couple of things that we've not talked about, which is we will get there, the config server, the API gateway, we will get there. But for now, what we have done is to split up our, the whole application that was resided in one code base into microservices. So we have the account service here, and we have the payment service here, and then we have service discovery. Now, when a user makes a request to our application, it comes to the API gateway. How does the API gateway know which service to or know how to route this request? Now, it leverages on the service discovery for that. Now, all of these services are registered with the service discovery, so they all have their own database. Now, imagine that there is a fault here or a bug or something that's preventing the account service from starting up. It doesn't affect the payment service, and there is more other useful ways to handle errors. There is also something called resiliency. Our application is going to be made to be fault tolerant. So if there is something, if let's say the payment service is trying to communicate with the account service and it cannot, the account service is going to throw some kind of signal to the payment service, letting the payment service know that, okay, there's something wrong with me currently. So say we had so many requests coming into the payment service. Now, we want to scale this payment service so that it can easily handle those multiple requests. It is easier to just throw more resources to this payment service, and we don't have to bother about the account service. Our application is more efficient, faster, and reliable. But if we were using this the monolithic architecture, we would have to throw those resources at the whole of this stack, and that would give us less performance. So let us get on now to continue with our microservice.